This is R.D. Sharma solution, class 12, chapter 12. Higher order derivatives. Exercise is 12.1. Find the second order derivative of the following function, x cube plus 10x. Now, higher order derivative or second order derivative, it is all about deriving multiple times. How many times you have been asked? So, dy by dx is the first derivative or derivation. In second derivative, we derive the derivation. Okay. So you have to differentiate this function twice. So d2 by dx2 is nothing but differentiation of x cube plus 10x twice. So let us regard this as y equals x cube plus 10x as a function. So we have an algebraic function also and the trigonometric function also. So you need to know the differentiation of all these. Then only you will be able to understand the higher order derivative. So dy by dx is first order derivative, x cube is 3x square, 10x differentiation is sec square x. Then we have the d2y by dxt. So we have d by dx of dy by dx, that is the second order derivative. So this will be d2y by dx2 on the left hand side. On the right hand side you have to differentiate again. So 3x square differentiation is 2x. Sec square x, the differentiation is 2 sec x, and then the differentiation of sec x is sec x tan x. So what do you get? 6x plus 2 into sec and sec will be sec square x. Then we have tan x. Okay. So now you see, if you have to write it in your exam, then this is the way you have to write. Like you have to say we have differentiating with respect to x, again differentiating with respect to x. Find the second order derivatives of the following function. Now we know already how to do this, okay, differentiating twice. So this solution, those who want to do by themselves, they can do it. I'll take a different approach. So y will be equal to sine log x. So first we have to find out dy by dx, that is y prime, y dash. So you can just write it as y prime also, y dash also. This is equivalent to saying that it is dy by dx. So d2y by dx2, this y prime will become y double prime. So sine theta, what is the differentiation of sine theta? It will be cos theta. So it will be cos log x. Now you have to differentiate the log x also inside. Okay. So sine is cos log x is 1 by x. So y prime is cos log x by x. So as we know, by normal differentiation, there are two ways to do it. You can use the product rule also. You can use the other way, that is the quotient rule also. So d2y by dx2, which is equal to the y prime, double prime actually. So on the left you see already have provided the solution for those who just want to go ahead. So I am doing it using the better way is to do it using quotient rule. So we have the square of the denominator, so x square, and as I said, cos log x into 1 by x can be done by the product rule. So we'll be following the quotient rule here. Okay. So this is there are different approaches for the same question. Whichever you are comfortable with, you can follow that. So the denominator becomes square, now denominator, and differentiation of cos log x. So cos log x will be minus sine log x, cos is minus sine log x. So it will be minus sine log x, and then differentiation of log x will be 1 by x. So I'll just put the negative sign just now. But let us see, you have in question rule, you have a negative in between. Now cos log x will be outside. Now you have to differentiate this one, the denominator. So differentiation of denominator, which is x, is just 1. X to the power 1 you can assume like that, and nx to the power n minus 1 you can apply. So as I said, this is minus sine log minus sine log x. So I'm putting a minus sign here, and here also we have a negative cos log x. So you can cancel these two, xx, negative you can take common, minus common. So inside this will be sine log x plus cos log x. So negative is outside. Now in the denominator you can just square it. So this is your final answer. Both way, by product rule or quotient rule, you are going to get the same answer. Next one is log sine x. Same thing we have to do. Second order derivative, that is differentiate the function twice. So you have y equals log sine x. Let us differentiate it with respect to x, or you can also write it as y prime. Log theta or log anything is 1 by that thing. So 1 by sine x. Differentiation of sine x will be cos x. So cos x by sine x is simply cot x, and we know the differentiation of cot x. So y double dash will be quite easy here. Cot x is minus cos x square x. So the second order derivative of log sine x is nothing but minus cos x square x. You have to write like this. Now find the second order derivatives of the following function, e to the power x sine 5x. So you have to differentiate it twice. Okay, those who want to do by themselves, but we will do it. We all will do it. E to the power x sine 5x. So e raise x, sine 5x is cos 5x, and differentiation of 5x will be 5. This will be 5 e raise x cos 5x. Then we have a plus. So now you can take this sine 5x outside, and differentiation of ex will be ex, e raise x. Okay. Now this is only the first differentiation that we have achieved. But since the question is asking about second order derivative, y prime y double prime we have to find out. D2y by dx2 we have to find out. So now there are two different terms with an addition sign in between. So what we'll do, e to the power x or e raise x cos 5x we will take separately. Cos 5x is minus sin 5x, differentiation of 5x will be 5. E raise x we have just kept it like this because we are applying the product rule here, product rule. Then we have the cos 5x will not touch, will only differentiate e raise x as I just suggested. We are following the product rule. E to the power x will be e to the power x only. So this is the 5 also. 5 is to be multiplied. So minus 5 e raise x sin 5x, and this 5 5s are 25. So there is a 5 inside also. Then we have plus 5 e raise x cos 5x. Alright. Now this is for this one only. This is the first part. Now we'll do the second part. So e raise x sin 5x. So e raise x sin 5x is cos 5x. 5 will come outside because 5x differentiation is 5 only. Then we'll not do the sin 5x. We'll only do the e raise x. So sin 5x, e raise x will be e raise x only. So now just add them because it is addition only. Now e raise x, sin 5x, e raise x, sin 5x, they are two terms. So 1 is there and minus 25 is there. So 1 minus 25 is minus 24. So minus 24 e raise x, sin 5x. Then we have this 5 and 5 will become, this will be 10 and e raise x cos 5x. So it will be plus 10 e raise x cos 5. Okay, so this is your final answer, but you can also simplify it more. First of all, negative sign is always kept wherever it is possible in between. So 10 e raise x cos 5x we will take first, and then negative 24 e raise x sin 5x. But by doing this, we also see that e raise x is common between these two terms, and also if we can take 2 also common from these two terms. So this we will do like this. 2 I am taking outside. E raise x I am taking outside as common, and what will be inside? It will be 5 cos 5x, and here you have minus 12 sin 5x. Okay, so are they matching? Yes, they are matching. So this is how you can simplify also. So write the answer as simplest as possible. Now same thing here, almost same as the previous question, but we'll do it. Those who just want to go ahead because they have understood how to do this, they can move on to the next question, but I'm going to do this. E raise 6x cos 3x, y prime is e raise 6x, we'll keep it like that. Cos 3x will be minus sin 3x, minus sin 3x, and then differentiation of 3x will be 3. Then we have plus cos 3x will remain like this. E raise 6x, so e raise 6x, differentiation of 6x will be 6. Okay, so let us multiply whatever is there. We have a negative here and we have 3 here, so put 3 here. E raise 6x will be there and sin 3x. So we have first term like this. Remember, it is just the first derivation. Second one is 6 e raise 6x cos 3x. So you can match this. If you, as I said, who want to do by themselves, they can just have a look. They can refer to the solution. Now, we have to put this negative in between. We always say that negative should be in between. So, I'm just swapping the terms. It will be 6 e raise 6x cos 3x minus 3 e raise 6x sin 3x. Then we will do the differentiation again. That is the second order derivative we have to compute. So we'll just forget about the constant right now. We'll concentrate on e raise 6 cos 3x. But what do you see here? E raise 6x cos 3x has already been done. The question is only this one. So we can just directly take this content and just put it here in the place of differentiation of e raise 6x cos 3x. So I have a 6. Now I am writing the y prime, which is the differentiation of the actual function as it is. So it will be 6 e raise 6x cos 3x minus 3. Then we have e raise 6x sin 3x. So we'll take the common later because we are going to solve it, and I'm multiplying it. 6 6 is 36, 36 e raise 6x cos 3x, and then we have 6 into 3, that is 6 3 is 18, 18 e raise 6x and sin 3x. We'll take e raise 6x common later, but there are certain terms which are coming from the second term also because we are doing the second differentiation of e raise 6x sin 3x. So we'll multiply it by 3 later. Let us do e raise 6x sin 3x separately. So e raise 6x sin 3x, so e to the power 6x, sin 3x will be cos 3x, differentiation of 3x will be 3, plus then we have sin 3x, differentiation of e raise 6x will be e raise 6x, differentiation of 6x will be 6. So what do you get? 3 e raise 6x cos 3x, this is the first one, plus we have 6 sin 3x, then we have e raise 6x. Now you have a 3 also here. So let us first multiply it by 3, and there will be a negative sign also. We'll just change the sign and add it to the first term. So 3 is a 9, 9 e raise 6x cos 3x, and then we have plus 6 is a 18 e raise 6x sin 3x. Along with this, we have this term. This is negative. So I am taking this, what we have done, and I am putting it in this equation. So it will be 9 e raise 6x cos 3x minus 18 e raised 6x sin 3x. As I suggested, these because it is negative, so we have just changed the sign. Now combine the equivalent terms. So e raised 6x cos 3x here also. So 36 minus 9 is nothing but 27. So write it as 27 e raised 6x cos 3x. And what about the other two terms? Because we have the similar terms, which is e raised 6x sin 3x. Minus 18 is minus 36. So you have negative 36 e raised 6x sin 3x. This can be a final answer, but you can resolve it more to write it in a simplified way. So we have the 9 multiple here. So 9 you can take out. 9 3s are 27 it is. E raised 6x also you can take common. So you have 9 3s are 27 here. Cos 3x minus, what is it? So we have 4 sin 3x. So this whole term is this one, which is also the answer. Find the second order derivatives of the following function: x cube log x. Okay, see x cube log x, this is quite simple. If you want to just go ahead. X cube log x. So I'll not write all that we have differentiated with respect to x. I hope that you'll be able to write it. So let us differentiate it, find out the y prime or dy by dx. So x cube, and then log x is 1 by x, then log x, differentiation of x cube is 3x square. We have applied the product rule. This gets cancelled. You have x square plus you have 3x square here, then log x. Again we have to do the differentiation. So this was y prime. We have to find out y prime. We have to apply the y prime differentiation of this again. X square is 2x, then 3 differentiation of x square log x. Let us do it separately. X square log x is 1 by x plus log x, differentiation of x square is 2x. So just cancel this, you get x plus 2x log x. Now just put it here with a multiple of 3. So 3 into x plus 2x log x. You get 2x plus 3x plus 6x log x. 2x plus 3x is 5x plus 6x log x. This will be your final answer. If you want to see the answer also and how you're going to write it, this is how you're going to write it. But do remember, you have to write it very neat and clean and with all the wordings and sentences like this. You have to show each and every step to the examiner or the teacher. Now we have an inverse trigonometric function here, which is tan inverse x. And I hope you have all the idea about the differentiation of the inverse trigonometric function. So y equals tan inverse x. Y prime, that is dy by dx, is tan inverse x is 1 by 1 plus x square. Now y double dash, that is the double differentiation is, now you can do two things. Either you can use the quotient rule or you can make it simpler, because anything which goes up, the power sign will be negative. So 1 plus x square, when it goes to the numerator, it will have a negative sign. And you know x to the power n differentiation is n x to the power n minus 1. So minus 1 plus x square to the power minus 1 minus 1. Minus 2 you can write. So 1 plus x square differentiation has also to be done. 1 plus x square is 2x. You just write 2x. So you have a negative 2x, and 1 plus x square to the power minus 2, you can bring it down. So you have 1 plus x square here, and this is going to be your final answer, which is going to be your double differentiation. Alright. Now we have x cos x. Let us do it quickly, because now I hope you have got a fair idea. X cos x, y prime or differentiation dy by dx is x, cos x will be minus sin x. I am applying the product rule. Then cos x will be like that only, differentiation of x will be 1. So you have, and cos x I am bringing first, then minus x sin x here. So now we have to do the differentiation again. So this will be double differentiation, which is the second order derivative. Cos x will be minus sin x, and then x sin x I will do it separately. X sin x is x, sin x will be cos x. Then we have sin x, differentiation of x will be 1. So this, when I will write it here, I have to change the signs. So minus x cos x minus sin x. Now you see minus 2 sin x it will be there, because there are minus sin x and minus sin x will be minus 2 sin x. You already have a minus x cos x. Now you can take a negative outside, you will get 2 sin x plus x cos x. So this is y double dash, or you can say d2y by dx2, or the second order derivative, or the higher order derivative of x cos x. Log of log x, y equals log of log x. So differentiation of log anything will be 1 by that thing. So dy by dx of log x, y prime is so 1 by that thing. So 1 by log x. Now you have to differentiate log x again. Differentiation of log x is 1 by x. So you have 1 by x log x. Now there are two ways. Either you apply the quotient rule, or as I just said once, one question before, I guess, just take it in the numerator with a negative as a power. So x log x to the power minus 1, and you know that this x raised n differentiation is nx to the power n minus 1. Minus 1 come in, 1 will here, x log x to the power minus 1, that is minus 2. So now you have to do x log x also. So x log x differentiation is x log x is 1 by x plus log x. You can just write it as log x, differentiation of x will be 1. So you have 1 plus log x. So just write 1 plus log x here. You have a negative x plus log x to the power minus 2 can be taken into the denominator. So you have 1 plus log x negative, and you have x log x in the denominator square. So this is the answer. As I said, there are multiple ways to do it. It's up to you how you do it. You can apply this way also. You can apply the quotient rule also. But the main essence is you have to differentiate the content of the function twice. That will be regarded as the second order derivative. Okay, this question we'll take in the next discussion. Till then, thank you so much and take care of yourself.